Okay, so have you ever like flipped through a deck of cards and then suddenly there's this like totally wrong card,
Oh,
like
yeah.
a red six of spades or
Yeah,
something?
I get
That just
yeah.
like throws you off, right?
Totally. It's like your brain just kind of freezes for a second trying to figure out what it's seeing.
Exactly. And it's interesting to think about how that like little brain glitch kind of mirrors how we react to these like big, really disruptive ideas in science.
Right. And like one of the biggest examples of that has got to be the whole concept of extinction itself.
Oh, absolutely. For centuries, people were finding these like bizarre fossils things that clearly didn't match anything alive, but the idea that an entire species could just vanish, it was just unthinkable.
Yeah, it was like that red six of spades. Like it just didn't compute. It took a serious, my God, moment to shift that whole paradigm.
And you're totally right. Like, think about Cuvier and those mastodon teeth. He realized there was just nothing like it in the living world. And that was like a huge turning point. It finally forced people to accept extinction as a reality.
And even once extinction was like on the table, there were still these major shifts in how we understood it.
Oh, for sure.
Yeah.
Like you had Cuvier's catastrophism where these huge unimaginable disasters would just like wipe the slate clean over and over again.
Right. And then you have Lyell and Darwin coming along with this idea of uniformitarianism, which was
Mhm.
all about gradual change and competition, slowly weeding out species.
So it was much more subtle view of things. But then another one of those, my God, moments hit with the discovery of the iridium layer at the KPG boundary.
Oh, yeah. That was a game changer. And it's kind of led us to where we are now with this idea of
Where
neocatastrophism.
basically things are mostly slow and steady, but then you have these occasional but like massively impactful bursts of rapid change.
Exactly. And those rare events, even though they're super brief in geological time, they've had a profound impact on shaping the history of life.
And that brings us to these like moments of rapid change,
Yeah.
the mass extinctions. And today we're going to really dig into one of the earliest and most significant of these, the Ordovician extinction.
Which happened around 444 million years ago.
Now, most people, when they hear extinction, they immediately think dinosaurs.
Right.
But this was way before that. The Ordovician extinction was like the first of the big five.
And it was absolutely massive, wiping out an estimated 85% of marine species.
It was a total reshaping of life on Earth. And to understand it, we really need to look at the bigger picture, the geological context of the Ordovician.
So at this time, most of the Earth's land masses were clustered together in this giant supercontinent called Gondwana.
Right. And one of the key locations that our source material highlights is Dobbs Lynn in Scotland.
Which back then was down in the southern hemisphere at the bottom of an ocean called the Iapetus.
And this was a period after the Cambrian explosion. Remember when life in the oceans just exploded in diversity? It's called the Ordovician radiation.
So there was just this incredible abundance of life to be lost.
And Dobbs Lynn itself is like this incredible time capsule. It's got these layers of rock that actually record the extinction event.
And one of the key pieces of evidence comes from these fascinating little creatures called graptolites.
Now, for anyone who's not a geology buff, graptolites were these tiny colonial animals that they lived in these connected tubes called acariae, kind of like little apartment complexes.
And they came in all sorts of amazing shapes, like eyelashes, zippers. Some even look like tiny trees.
And what makes them so useful is that they were super sensitive to environmental changes. So they're like these perfect indicators of past environments, index fossils.
And at Dobbs Lynn, you can actually see this really dramatic change in the rock layers.
Yeah.
You've got these dark shale layers that are just packed with all these different graptolite fossils.
And then right above that, you have these lighter colored stones where the graptolites just vanish.
Almost completely. It's like this stark line between a thriving ecosystem and then suddenly almost nothing.
It really points to this like super rapid shift from a habitable to an uninhabitable seafloor. And scientists are doing some really cool work with isotope chemistry to pinpoint the exact timing of this change.
To really nail down the timeline of how quickly things went south.
It's kind of wild to think about holding a rock full of these teeming, diverse fossils, and then another one from right above it with basically nothing.
Yeah, it really drives home how extinction can permanently alter even the most successful life forms.
The source makes this really interesting point about the V-shaped graptolites that were super common in the Ordovician. They were totally wiped out.
And in the Silurian period that came after, you see these more streamlined, stick-like graptolites taking over.
And that original V-shape never came back. It's like this small-scale example of the huge impact extinction can have on the whole trajectory of life.
And that leads us to this crucial question. What actually caused this massive die-off in the Ordovician?
Right, because for a while after the Alvarez hypothesis about the asteroid impact that killed the dinosaurs, There was this kind of rush to find like a single unifying theory for all mass extinctions.
Like impacts were the go-to explanation for a while.
And there was that whole Nemesis affair, remember?
Oh yeah, this idea that there's this like hidden companion star to our sun that periodically sends showers of comets our way.
It totally sounds like science fiction, right? Like a Death Star that just keeps bombarding Earth.
But as our source points out, the evidence for this regular cycle of impacts just wasn't there, and there's no sign of the star itself.
And while scientists did find some higher than normal iridium levels in Ordovician rocks at Dobbs Lynn, they didn't find other key signs of a giant impact, like shocked quartz,
Right. So the focus shifted to other possible causes, and the evidence really points to a significant drop in CO2 levels in the atmosphere.
which would have led to global cooling and the expansion of glaciers on Gondwana.
Exactly. And that would have caused sea levels to plummet and messed with ocean chemistry big time.
It's a very different scenario than what we see with the end Permian extinction, the biggest of the big five.
Right. That one was likely triggered by a massive release of carbon, leading to intense global warming and ocean acidification.
And possibly even hydrogen sulfide poisoning, which would have created these like incredibly vivid purple seas and pale green skies.
It's kind of unsettling to think about how these huge planetary shifts can happen relatively quickly, at least on geological timescales.
Yeah, the end Permian extinction, even though it was so devastating, seems to have played out over less than 100,000 years.
Which is basically the blink of an eye in Earth's history.
And when you look at the Ordovician, the potential causes are just as mind-boggling. Our source even talks about this hypothesis that early land plants like simple mosses and liverworts might have played a role in the Ordovician glaciation.
Because they would have drawn down CO2 from the atmosphere.
So essentially the first major animal extinction might have been partly caused by plants.
It really shows how complex these events are. There's no one-size-fits-all explanation for mass extinctions. Each one had its own unique set of triggers and consequences.
And that brings us to this concept of the Anthropocene, this proposed new geological epoch defined by the impact of one species.
Right.
I mean, we've talked about these other huge my God moments in our understanding of Earth's history. And the idea of the Anthropocene feels like another one of those major shifts in perspective.
For sure. And there have been other names proposed too, like catastrophizoic or homogenocene or mixocene.
But Anthropocene, which was popularized by Nobel Prize-winning chemist Paul Crutzen, that seems to have stuck.
Yeah, apparently he came up with it during a conference where everyone kept talking about the Holocene, which is our current geological epoch.
And he just kind of blurted out, let's stop it. We are no longer in the Holocene. We are in the Anthropocene.
And everyone just went silent for a second, and then it became the whole focus of the discussion.
I love that story. And what makes the Anthropocene so compelling is just the mountain of evidence showing how we humans have impacted the planet on a global scale.
Absolutely. The source lays out a bunch of key indicators, like how we've transformed huge chunks of the land surface, how we've dammed and diverted major rivers.
How we produce more reactive nitrogen than all natural processes combined, how we've overfished coastal waters, and how much fresh water we use.
And of course, there's climate change, the massive increase in CO2 and methane in the atmosphere.
And it's not just about the changes that are happening right now. The Geological Society of London did this study where they concluded that the Anthropocene is going to leave this clear, global stratigraphic signature.
A signal that'll be recognizable millions of years in the future.
It's crazy to think about that. Like, our actions are literally being etched into the planet's geological record.
And it's not just chemical traces either. There's also what's called a biostratigraphical signal.
Which is basically how humans have been moving species all over the planet, mixing them up and creating new ecological patterns.
And this is where Jan Zelasiewicz comes back into the picture, the stratigrapher we talked about earlier at Dobbs Lynn.
Right. He's actually the head of the Anthropocene Working Group. And his work studying the deep past those graptolites and the Ordovician extinction, it directly informs his understanding of the future geological record.
The record that's being shaped by us right now.
I think it's so cool how he connects these seemingly distant time periods. He's looking at the patterns and consequences of past extinctions to understand the magnitude and the nature of the changes that we're causing.
And one of the things he's particularly interested in is the fate of rats in the Anthropocene.
I know that might sound weird at first, but his reasoning is actually really fascinating.
Yeah, because rats have followed human migration and trade routes to almost every corner of the planet. They're like this powerful biostratigraphical signal of our own dispersal.
Like, think about the Pacific rat hitching rides with Polynesian seafarers, or the Norway rat spreading with European explorers.
They've had huge impacts on ecosystems, even contributing to deforestation on Easter Island.
Wow. So Zalesevich sees rats as being incredibly well suited to thrive in this new ecospace that's emerging as a result of the current extinction event.
Right. And he even speculates about the possibility of future giant tool-using rats.
I mean, it's definitely a thought experiment,
Hmm.
but it really highlights these long-term and potentially unforeseen consequences of the changes we're causing.
Exactly. And ultimately, the source emphasizes Zalesiewicz's view that the Anthropocene is this truly remarkable episode in Earth's history. There's nothing else quite like it.
It's this unique combination of factors: climate change, the legacy of nuclear testing, river diversions, monoculture farming, ocean acidification, and the huge movement of species.
And all of that is going to leave a very clear and permanent mark in the geological record.
So to sum it all up, the evidence is really overwhelming. We've entered this new geological epoch, the Anthropocene.
A time defined by human impact on a planetary scale.
And while it shares some similarities with past mass extinctions, the underlying causes are uniquely our own.
It's another one of those my God moments when you realize the sheer scale of our influence. We're literally a geological force shaping the future of the planet.
Which brings up this really interesting question for everyone listening. If the future geological record of our time is going to be squished down into this relatively thin layer, what's that layer actually going to reveal to future geologists millions of years from now?
What kind of stories will our fossils and our chemical signatures tell?
It's a powerful thought, right? To think about your own place in this unfolding geological drama and the legacy that we're all creating.
Absolutely.
Okay, well, on that note, I think we're going to wrap up for today. Thanks for listening,
Thanks for having me.
and we'll see you next time for another deep dive.
See ya.
Bye.